we derive the expression of Compton shift. For this, let us consider a photon collide with a atom like this, and the energy of the photon is E equal to h nu, and after collision a scattered photon with energy h nu prime came out with a scattered electron with the velocity v came out. Okay, and this angle is phi and this angle is taken as theta. This is the Compton effect. Now we derive the Compton shift due to this effect. Okay, first of all we take the energy conservation. That is, the energy of the photon is h nu before collision plus, sorry, it will be the energy of this electron that is at rest, that is m naught c square, because the electron is at rest, so the mass will be m naught, that is rest mass. And after collision the energy of photon h nu prime plus the energy of the electron after collision, that will be mc square. Here m is the moving mass and m naught is the rest mass of the electron, and the relation between them is m equal to m naught by root over 1 minus beta square, where beta is equal to v by c. V is the velocity and c is the velocity of light, and v is the velocity of the electron, and this equation is given as 1. Now we take the momentum conservation case. And first, horizontally momentum conservation. For this, the horizontal momentum of this photon is h nu by c, plus the electron is at rest before collision, so the momentum is 0, and after collision the momentum of the photon is h nu prime by c plus into cos phi, plus the momentum of the electron after collision is mv cos theta, that is theta. Okay, so h nu by c minus h nu prime by c cos theta equal to mb cos theta. And now vertically momentum conservation, it will give us that it has no component vertically before collision, so it's 0, and the electron has also no component because it's at rest, so it's 0, and after collision it has vertical component as h nu dash by c sin phi, sorry, it will be phi because the angle of the scattered photon with horizontal is phi, because that is phi, so it will also be phi because this angle is phi. Okay, now after collision the electron have the vertical momentum with mv sin theta, that is mv sin theta, and the negative sign because the vertical component is to this direction, that is opposite to the photon's direction with vertical, so it will be like this. Now we take this as equation 2 and this equation 3. Now doing this operation 2 square plus 3 square, we get, squaring these two equation, you get h nu by c minus h nu prime by c cos phi whole square plus h nu prime by c sin phi whole square, that's equal to this term, that is m phi cos theta will be m square v square cos square theta plus this term whole square, that is m square v square sin square theta. Now expanding this, we get h square nu square by c square plus h square nu prime square by c square cos square phi minus 2h square nu prime by c square cos phi plus h square nu prime square by c square sin square phi, that is this term, and that is equal to, if we take m square v square common from this, we get cos square theta plus sin square theta, and their value is 1, so it will be 1. Now from this is will h square nu square by c square plus h, from this and this we take common h square nu prime square by c square, so it will be cos square phi plus sin square phi, and the value is 1 minus this term, that is 2h square nu prime by c square cos phi, that is equal to m square v square. Or now we multiply c square on both sides, so it will be like this. After multiplying c square on both sides, we get like this, and take this as equation number 4. Now from equation number 1 we get that from this h nu plus m naught c square minus h nu prime, that's equal to mc square. Now we square on both sides of this equation, and after doing this we get like sorry, that will be okay. Now we expand this, it will be h square nu square plus m naught square c to the power 4 plus h square nu prime square plus 2h m naught nu c square minus 2h m naught nu prime c square minus 2h square nu prime. After expanding this square we get this is equal to m square c to the 4, sorry, it will be m normal m, so that is this. And we know the relation of m and m naught from this, that is the moving mass is equal to rest mass by root over 1 minus beta square, so it will be m square by 1 minus beta square into c to the power 4. Okay, and name this as equation number 5. Now we do an operation that we subtract equation 5 minus 4, so 5 minus 4, we doing this, we get this term and this term will be cancelled out, this term cancelled out after 5 minus 4 operation, and the remaining this term, that is m naught square c to the 4 plus from this and this term we take 2h m naught c square common, so it will be nu minus nu prime minus this term, that is 2h square nu prime plus this term, that will be 2h square nu prime cos phi, that's equal to m naught square by 1 minus beta square c to the power 4 minus this term, that is m square v square c square. Okay, thus m naught squared this term plus 2h m naught c square nu minus nu prime we take common 2h nu prime from this, so it will be 1 minus cos phi, that's equal to m naught square by 1 minus beta square c to the power 4 minus m square. Now we know that beta is equal to v by c from this relation, so v is equal to beta c, and now we can put this relation there, so it will be beta square c square into this c square. Okay, now this equal to m naught square by 1 minus beta square c to the power 4 minus m square beta square c to the power 4, and that's equal to m naught square by 1 minus beta square c to the power 4 for this moving mass, that is equal to m naught by 1 minus beta square into beta square c to the power 4. Okay, and that is equal to m naught square by 1 minus beta square. We take common this term, that is c to the 4 can be taken common, so that is common, so that will be 1 minus beta square. After taking common this, we get this, and this term cancelled out, so it will be m naught square c to the 4. Thus we get this is equal to this, so m naught square c to the 4 plus 2h m naught c square nu minus nu prime minus 2h square nu prime, and this can be written as 2 sin square phi by 2, and that is equal to m naught square c to the 4, and this term cancelled out, so the remaining 2h m naught c square nu minus nu prime, that's equal to 2h square nu prime into 2 sin square phi by 2. Now these two and this two cancelled out, this h and this one is cancelled out, so m naught c square, and we divide nu prime on both sides, so it will be 1 minus nu prime by 1 minus nu, that is equal to 2 sin square h sin square phi by 2, and this is equal to m naught c, and we multiply on c and there, so it will be c by nu prime and c by nu, that is equal to h sin square phi by 2 into m naught c, and this term can be written as lambda prime because c by nu equals to lambda, so that is lambda, so it's 2h sin square phi by 2. So from this m naught c, and this is the wavelength shift, so the lambda sin square phi by 2, thus we get del lambda, that is the Compton shift, so thus del lambda is equal to 2h by m naught c sin square phi by 2. This h by m naught c can be taken as lambda c, that is lambda c into sin square phi by 2. This lambda c, that is h by m naught c, is called the universal constant of Compton shift or Compton wavelength, that is universal constant of Compton wavelength, that is lambda c equal to h by m naught c. Thus we get the expression of Compton shift, that is 2 lambda c sin square phi by 2.